Thank you. Now, I'm doing the talking for both of us because I don't think Jim will take too much time. So just briefly, our talk will be on the new Design Rainfalls released by BOM in 2016. So what is Design Rainfalls? To some of you it might not mean much, but basically they're used in the design of drainage systems as a probability function. Now, they're used because using a single station nearby to your region of interest isn't reliable, so we have these IFD tables, and they're a consistent method for estimating total rainfall depth for a given storm. Now, there are two versions in current use, ARNR 87, the old version, and the BOM 2016. And the ARNR 87 are slowly being phased out, not yet, no one knows when they'll be. And in between there was an interim BOM 2013, and they're now superseded by the BOM 2016. So across Australia we have all these temporal patterns. On the left you're just seeing the old from the ARNR 87 and the new version. There isn't, from ARNR 2016, there isn't that much difference in how the temporal regions of Australia have been outlined. Now just for this presentation we'll be focusing on mostly 8 combinations of duration and frequency, and those are at the 50% AEP, which is, for the old people out there, it's equivalent to the 1.44 year ARI, and the 1% AEP, which is just the 100-year ARI. Now, this is just to get an idea of where Perth sits in these design rainfalls compared to other capital cities. So these are just these same 8 combinations. These are the rainfall depths, and these are the factors in regard to the other metro areas. And as you can see, if you're looking at Sydney, Brisbane and Darwin, they're getting about 3 times as much rainfall. For when they're designing their stormwater drainage, their rainfall depths are about 3 times higher. You can see Perth is more closely related to Melbourne and Canberra, sort of around the 1. Perth is given in all these ratios is 1. And this is just the same sort of graph. We're just seeing these are the IFD curves, and what I quite like about these is how just the appearance of the curve. You can see the black down here is Melbourne and Perth. They're similar types of rainfall depth on the y-axis. Similar rainfall depths across all durations there's 10 minutes down here going up to 7 days. And then you're seeing those Sydney and Brisbane, which have the multiple factor of 3 comparative to Perth. So they're basically just getting higher and higher for the longer durations, more rainfall. Now this is the old IFD table from ARNR 1987. Now these were computed based on a couple of parameters, which you can still download the old version from the ARNR website. From the BOM website, and they basically just use these parameters. And so you've got 6 combinations from the 6 master sheets. You've got some skewness factors, some short duration factors, and then from just these values, this whole IFD table is produced. So what has changed from the ARNR 87 IFDs to the 2016? The biggest change is the fact that there are more stations which these design rainfalls can be computed from. And also there's a different frequency analysis which is applied to it. Now, one of the major changes is actually the terminology, and trying to get that terminology across to people can be slightly difficult, just because there are exceptions. Like, for example, the old terminology, ARI, average annual recurrence interval, most people are quite familiar with that, sort of the 1 year, 5 year, 10-year ARI. And so the AEP, annual exceeding probability, is just the inverse of that. But it doesn't apply for the 2 year and the 5 year. as a disclaimer in most of the documents say. Now, in the old 1987 IFDs, if we look at IFD stands for intensity, frequency, duration. The IFD tables were expressed with intensities. They had a frequency from 1 year to 100 year ARI, and their durations range from 5 minutes to 72 hours. On the BOM 2016 IFDs, now we're seeing them expressed as both rainfall depths and as intensities. Now they're going from 12 EY, which is basically the frequency of once per month, to up to the 1 in 2,000 AEP, my apologies. And instead of the 5 minute to 72 hour durations, we're now going down to 1 minute up to 7 days. Now these are just some, I quite like these graphs. These are just showing you Perth as a factor of 1 and how the rainfall, design rainfalls is changing across WA. So Perth is just roughly down here at 1, and what you're seeing is moving east, rainfalls, the design rainfalls are probably about 20% less, and then again slowly moving up to sort of the Kimberley region, you're seeing the rainfalls about 2.5, the factor of Perth. Now this is just showing you a couple of durations. We've got 5 minutes and 1 hour for the 50% AEP. And these are just the 24 hours to 72 hours. And what you're seeing is a similar pattern across these combinations. How you get the design rainfalls are lower the further you go east, and then around this middle section here, then they start to increase again going northward. And this is just a close-up of the southwest to just see what's happening here. And what's quite interesting is you do see that you do get higher design rainfalls on the Darling Scarp, just a bit more than Perth, yet on just westward of that, they are marginally lower than Perth. And then you still see that trend from the wider maps of a slow decrease, a lower design rainfall moving eastward. Now these are just the same for the 1%, the same durations, and you are seeing this. Now you're seeing that the design rainfalls have increased eastward. For the shorter durations, yet for the 24 hour and 72 hours, they are very similar or just marginally lower. Now, these are the old design contours in the AEPs 87, and what you're seeing there is this 3 contour, which is Perth is at 2.2 to 2.2 millimetres per hour design rainfall at this 50-year ARI 72 hours, and what you're seeing here is a large 3 contour in the centre of Western Australia. And if we just go back, that's sort of this region around here. That's where the design rainfalls start to increase as you go both northward and towards the coast in the northwest direction. And what you're seeing here is the current and historical BOM rainfall gauging stations. And you're seeing that most of them are along the coastal areas, and moving further inland, they are more scattered. Now, in the office, we did an analysis of comparing what has happened between the 1987 IFDs and the 2016 IFDs. And so we've just done this percentage change calculation for the centroid of each local government area in WA, plus some significant towns and cities, to see if there's any variation between their location and the centroid that we've taken. And what we're seeing through our WA-wide analysis is that in the design rainfalls, there are significant increases in the Shire of Busselton and in the Shire of Augusta Margaret River and inland WA. And we're seeing decreases along the Darling Scarp and along coastal regions predominantly. Now this is just from Perth, what we're seeing across the durations. And you can see for the more frequent or 1EY storm, the design rainfalls have changed by approximately 5 to 10%. They're 5 to 10% higher. But as we move to the more rare events, you can see for these short durations, they're up at 10 to 20% lower than the old IFDs. Now, if we look at Busselton, it's much more bleak for whoever's designing there. You're seeing that basically for all durations and AEPs, the design rainfalls have increased significantly. We're seeing it 20 to 40%, which is suggesting that what's been designed there using the old IFDs is now significantly under-designed. Now, this is just a trend analysis which we did for the local governments in the southwest, and the dots are our significant capital cities, which we've also taken the IFD for. And what you're seeing is the green is a decreasing and the red is an increasing. You're just seeing that it's these coastal areas where you're seeing that green and the decreasing at the 1EY, and as you move further inland, you are seeing the rises from the old IFDs. And just at the 1% AEP, you're seeing more of that green trend along the coast. And apart from Wickerpin here, everything is decreasing predominantly. Sorry, everything is increased predominantly inland. So now we'll just sort of look at how does our Centroid for Bunbury compare to the city of Bunbury? Sorry, there we are. So because there's our Centroid where we've taken our IFD, and there's Bunbury. So how do the IFD tables compare? And in generally, there isn't that much variation. There's probably, for all the values, a 3% difference. If we look at City of Busselton and Busselton, again, it's still as bleak if we move further to the coast, where the values haven't changed much from the local government, the Centroid for the local government area, and when we've taken an IFD at the coast there. But Albany is the slight exception. Our Centroid is up here and we're down here at Albany. If we take our Albany Centroid, we're seeing basically everything is reasonably bleak, and all the IFDs have increased. But if we actually look at Albany, you'll see that, most of the design rainfalls have actually decreased since the 1987, particularly if we're looking at these short durations for the 5 minute. For say, gutter design, they use the 5 minute 1% AEP, and you're seeing that it's now 40% lower, the design rainfall for the new version. Now, just a brief application to see what the differences are along a WA-wide scale. Now, in the DWO decision process, when we're designing a stormwater system, we have to consider the small, the minor, and the major. Now, the small is now the first 15 millimetres, millimetres, not minutes, from the previous 1 year, 1 hour. The minor is a bit, no one knows what the minor is anymore. It used to be the 5-year ARI. Now, it could either be the 0.2 EY or the 20% AEP. There's no definitive consideration for what the minor is, but the major is still the 1% AEP. So now, these are just some difference maps that we've computed for WA to show you a couple of the durations of the 1% AEP. These are just the temporal areas again, because when we're modelling our systems, we're not only considering the design rainfalls, but the temporal pattern for those specific regions. And this is just showing you that for each duration that we're modelling now, in the new version of ANR 2016, we now have 10 temporal patterns to model compared to the one under ANR 87. So this is firstly the 1% AEP 5 minute, to see what's happening in WA. And you can see along the coastal areas, things have decreased by about 20% on this scale. As we move more inland, the design rainfalls have increased from 1987. I've actually excluded shy of megatharian here because it's at 60%, and it'll skew my colour ramp significantly. And here we are at the 1 hour, and similar inland, most of the durations have most of the design rainfalls have increased, but still along the coast, that is where the decreases in design rainfalls are happening. And again, Shire of Meekatharra is the outlier at plus 64%. If we're looking at the slightly longer duration at 24 hours, and again, at this point, everything's basically increasing marginally. Because you can see there's a couple shires where we're seeing decreases, but most along WA for the 24-hour duration 1% AEP, most of the design rainfalls have increased from the ANR 87. And finally, at the 72-hour, again, we're seeing this band in the centre where the durations where the design rainfalls have decreased, but everywhere else along WA, the design rainfalls have increased marginally. We're sort of in that sort of plus 0 to 10% increase along most of WA, apart from some areas around Albany and inland to Shire of Wickep and Narrogin there. Now just a summary. So for those who do work with designing stormwater drainage systems, there is a transition now from the ANR 87 to the BOM 2016 design rainfalls. No one's quite sure how to correctly apply them, just because some planning documentation which has been produced, say for urban water, the LWMS might have been using the ANR 87. So now in the next stage of development, do we still use the old IFDs or do we move to the new ones? And if we're moving to the new ones, then suddenly we're seeing an inconsistency with the previous documentation. So we are seeing that gradual transition to the BOM 2016 IFDs, but how we do so is a bit vague at the moment. And now, if we're looking at the design rainfalls, essentially what they're incorporating is 30 years more data. They aren't showing you what climate change is doing to design rainfalls. These are just showing you, with this more data, these are how our design rainfalls have changed from the 1987 version. And just as summary, we're seeing the increases in design rainfalls in inland WA and really along Busselton, Margaret River, that sort of small area. But then along most coastal areas apart from Busselton and Margaret River, the design rainfalls have actually decreased. I'm unsure for the reason for the Busselton and Margaret River anomaly, but essentially what we're seeing is the coastal areas have a high concentration of rainfall gauges, and so they seem to have, that's where the decreases have occurred, but as you move inland where the rainfall stations are fewer and sparse between, that's where the increases have occurred from the 1987 to 2016. And thank you for listening for that.